All right, everyone. We're going to go ahead and get started with a lecture here on Chapter 12 of this textbook. And this is a really important lecture because C# and so many other languages are classified as object-oriented. And that's the type of paradigm, if you will. It's the coding approach. And so there are other coding paradigms. There's functional programming. There's object-oriented. There is procedural-based languages. So not every language is object-oriented like C# is, but object-oriented has been a popular programming technique for probably 30 years now, since the 90s, really since Java. C# came around in the early 2000s as an object-oriented language, and that's what we're about to study here. We're about to study, well, what is an object? And so, what is a loop? What is an array? What is an if statement? What is a switch? All of these coding structures exist outside of object-oriented. So, those coding structures exist in procedural languages, in functional languages, and in object-oriented. So those are independent of programming paradigm. But what we're about to dig into is specific to object-oriented languages such as C#, such as Java, and a handful of others. And so these concepts are unique to that. And, so these are a new set of concepts that we did not talk about in JavaScript. JavaScript is referred to as object-based. Okay, so there's a slight difference there. And what JavaScript is kind of changed over the years. So that was what they used to call JavaScript, object-based language. That might even be updated. But regardless of that, that's not the important part. Again, I have the slide deck here for reference. Some of these things I'll reference closer than others, but if you guys have been following me most of the semester, this is just my backdrop. I like to talk it out in code a lot more than I like to go through these slides, and I think most most everyone listening prefers that way as well. So as I always do, we'll go ahead and get a new project going here, Chapter 12, homework or something. Kind of get that spinning up real quick. And I will make this code available to you guys to pull down on my repo. We'll put this in homework. Oh, let me put this in homework. Select the homework folder. Chapter 12, Demo 1. Always like to start a lecture with answering the question of why is this important? Okay, the topic is objects in C#. And so why are objects important? Again, object-oriented programming was around from the 90s, and I'll give you a picture, when I came out of school was the early 2000s, when I came out of Rankin and I entered the workforce. So about 20 years ago. Makes me feel old. Not old. At that time, in the early 2000s, procedural languages, by and large, were going away. Not completely, but a lot of the older procedural languages, I'm thinking off the top of my head, like COBOL. COBOL was a programming language that was popular for a long time, but you don't code in COBOL anymore. There just aren't jobs that do that. And these jobs were going away, and there was a new way of coding, that came out in the 90s, called object-oriented. And so people started going away from procedural languages and getting into this object-oriented. And when I graduated was the early 2000s. And so the people that had not yet switched from procedural languages into the newer, at that time, object-oriented languages, like I witnessed firsthand people coworkers that I had becoming laid off because they would not update their skills to go into the newer language. And so the newer style of coding. And so object-oriented languages have been fairly dominant for the last 30 years. So again, you talk about the types of coding, and I call them paradigms. Maybe there's a coding paradigms, coding approaches, right? You got the old procedural. Was one type, and then they came out with object-oriented, and one that's a little bit more common nowadays is functional. And so these are different methodologies, I guess. And depending on the language that you pick, you're either coding in an object-oriented methodology or functional or procedural. And so again, in the prior to the 90s, they had procedural languages. In the 90s, they introduced object-oriented, and now kind of gaining popularity. There's kind of this balance between object-oriented and functional, although which one's winning depends on where you are in the country, the job market in that particular sector. But functional and object-oriented are two different approaches. Anywho, we're studying object-oriented. C# is object-oriented. So why is learning objects in C#? OOP is still a dominant coding methodology today. And so there's lots of jobs that work with coding methodologies that are object-oriented. And so, what we're learning is the fundamentals of objects or OOP. And so, it's kind of like, why is this important? Well, it's a dominant methodology. All these companies have coding jobs that you will need to know OOP. And so in order to get a job, you might, be quizzed on, as part of your interview, your understanding of objects, and everything that comes with them. All of the OOP stands for object-oriented principles. Okay, that's OOP. So if you see OOP, it's really talking about all the things there are to know about objects. Okay, and there's a fair amount that really we're going to spend a lot of time in this class covering. Okay, this is our introduction to this, though. And so ultimately, if I could summarize all of this, why is this important? Well, object-oriented coding is a dominant coding methodology. And so if you want to get a job, odds are you're going to need to know OOP, object-oriented principles. So if I can condense that down, why is this important? Because a lot of jobs require it to be. So that would be my why is this important. We've talked about objects back in chapter 2 a little bit, and so I'm going to revisit what we've already said. We said early on, we'll see who remembers. Here's my first question. We said that something is a blueprint for an object. You guys remember that? Something is a blueprint for an object. You might go, oh yeah, what was that? I remember that. We talked about a blueprint of an object. So in Discord, you might need to go back and look it up from earlier in the textbook. It was more theory than, yeah, we got it. Class. A class is a blueprint of an object, and I'm going to break that down a little bit. What does that mean? So, step one, how do you create a class? What is a class? Well, a class is a blueprint for an object. So, the easiest way to create a class is if you right-click the project and go Add Class. So you add a class, or you could add a new item, and then in that object, or in that box, you can add this class right here. One of the core concepts in object-oriented principles is code reuse. As an example, we learned to code a method and then call that method many times. So we write a method once and then we call it so that we reuse that logic, we reuse that code. Keeping in mind, a method is a behavior. Okay? Methods existed in procedural languages. So in the old days, right, we had methods and we had variables. But there was no way, prior to object-oriented, there was not a single way, as we know a method is a behavior, but then there's also, very commonly, there's data. So if we're kind of like looking at like the common parts of a program, we have methods, and then we have data, and both methods and data existed in procedural. But in object-oriented, they wanted a way, so essentially, a way to tie in behaviors and data to a thing. The thing being the object. And so this is where it's a little bit vague in the terminology. But object-oriented programming, they said, okay, we've got methods and we've got variables, but in this new paradigm, that was in procedural, in this new paradigm, we want an entity, we want a thing that can tie in behaviors and data under one roof under one entity. And so that's where this idea of a class was born, right? A class is a blueprint of an object. An object is a digital representation of a real world thing. Objects have two components. They have methods and they have data. Methods are always called methods. Data, sometimes they call attributes. So again, take a step back. All right. What is an object? You take anything in the real world. My coffee cup. Okay? I want to make a digital representation of my coffee cup. So we need to make an object that represents coffee cup. So we would start by creating a class. A class to represent this thing. A real world thing. It's kind of like the class is very much like declaring the method. Declaring the method is, this is the code for the real world thing. The class is the code for the real world thing. When you call the method, then, is when you create the object. Okay, so let's get into this. I'm going to demonstrate how to add a class for my real world thing. Anything. A pen, a keyboard, a piece of paper, a book, anything. Think of a noun. A noun is a person, place, or thing. A person, place, or thing can be an object. Okay, it's a digital representation of a real world noun, of a thing. Okay, so in my class, coffee cup. My class is going to be called coffee cup. Notice it's got the class coffee cup. Okay, why am I doing this? Why am I creating a class for coffee cup? Why is this important? Let me go back here. Code reuse. When you create a thing in code, you can reuse that many times. You can reuse this as many times as you need. Keep in mind, classes have, what I say over here, classes have objects have two components. Classes have two components. Classes are made up of two things. Classes are made up of two things. Methods and data. What else can, again, anything. A student can be a class. And then every time a student enrolls at Rankin, we would create a new student in our software system. Right? Students have methods, things that they can do, and data, right? So a student name, a student first name, a student last name, a student social security number. They have students that have things that they can do. They can enroll in class. They can drop classes. They can graduate. You know, these are all behaviors that they do. So the methods are the behaviors of the class. The data are, the attributes of the class. Okay? So generically speaking, we're working with things in the real world and we're turning them into a digital thing, right? By making them a class. All right. Typically, your classes are marked as public, by the way. We'll get into these keywords public, but typically your classes are public. All right. Because classes are made up of two things, data and methods, I'm going to start actually with the data. Okay. So what pieces of data are about coffee cups? Well, these are variables that are for the first time we're gonna put, by the way, a public and private. You guys already know this. Access modifiers. Okay, they control scope. Scope of the data. Okay, in other words, what parts of the program can access this data? So we're starting with a private access modifier. That means private means it's very similar to our class level variables from before. They're accessible only to this class. So private means our data is only accessible to this class. So private is an access modifier. Again, talking about our coffee cup, we might have a cup color. Okay, that's a piece of data. What can the coffee cup do? Well, this coffee cup, the person can have a behavior. Let's say another current ounces of coffee. So a method, so let me back up just one tick here, by the way. An important term, we just covered an important term. These things here are called these are variables. These variables have data types. They have access modifiers to them. Okay? But these are very much like your variables inside of your methods. When you were declaring variables inside of methods, you just gave them a special name. You called them parameters. Okay, they were just variables. And those variables had a scope of those methods, right? Parameters scope are within the method. So you're in scope within the method. These variables are also given a special name called instance fields. Okay, and we'll talk about what that actually means. But again, so that's just a new term that we haven't covered before. But these are just pieces of data about our coffee cup. Methods are behaviors of the class. Oftentimes, our methods modify or access our instance fields. Okay, so this is our data, and just like before, our methods are working with our data. Our methods are working with our data. So if I'm thinking about like what can a coffee cup do? You know, what can a coffee cup do? I don't know, maybe fill the cup with ounces. The coffee cup can be filled with ounces. That's what a coffee cup can do. It could be filled. Okay, maybe on that same idea, maybe it could also be consumed from. So if we're filling our coffee cup with ounces, let's make a method. Now our instance fields, I'm kind of going with the current ounces of coffee. I'm not really messing with the cup color too much right now. I'm kind of going with this, how many ounces are in our cup. Our instance fields, I'm going over these access modifiers. Public for our class, very typical. Private for our instance fields, very typical. We'll elaborate on this. Typically our methods then, when we're working in a class, okay, we're not in the form code. This is our form code, form1.cs. And I did take some notes over here, but I'm not in this code anymore. Remember, I created a new file. This new file here is called coffeecup.cs. Right? So if I close everything, I'm just working in this new file right now. Now the form is going to be able to use that file in a reusable way. We can create thousands of coffee cups. And each coffee cup is going to have data about it that's unique. Each cup can have its own color. Each cup could have its own number of ounces that are set. So how do we, let's get back to our method. Methods are typically going to be public. This method is just going to be called fill the cup with 8 ounces. That looks like 80. So I'm going to spell the word 8. Current ounces of coffee increased by 8. So this is an important concept, okay? Again, sounding like a broken record, everything's important, but this is an important concept. These instance fields, here's the important concept. Methods are used to insert, update, delete data from our fields. The more code that we write, you're going to see it's all about working with this data. But this data is set to private. These instance fields are set to private. And what that does, marking these as private, means that we cannot access cup color from our form, right? Over here's our form. Cup color is not accessible. Directly accessible. This provides a layer of security to our data. Cup color, or I'll even, since I'm not doing cup color, current ounces of coffee. The current ounces of coffee variable is not directly accessible. This provides a layer of security to our data. Instead, we can only modify the data through our methods. So we have controlled access when we're creating a class only by using these methods can we modify our instance fields. This is a concept in object-oriented programming called data hiding. Data hiding is an object-oriented principle So what is data hiding? Data hiding means setting our instance fields to private and only enabling the users of our class to modify or access the data through methods, which are public methods. So data hiding is like one of those principles that I was talking about. Objects, classes, and objects. Classes have attributes and they have behaviors. Attributes and behaviors are the things that objects and classes are made up of. Okay, right now we're just focusing on the class. You notice we set our instance field called current ounces of coffee, and we modify that through this method. This method is fill cup with 8 ounces. I could make another method called fill cup with 4 ounces, fill cup with 12 ounces. You know, I can make all these different methods to say how much to fill the cup. Maybe depending on what the customer buys, you know, we can call different methods to fill the cup. Public void, if we're going to write one called consumed, drink, let's just say drink. And let's just say that a drink subtracts, I don't know, what's a gulp? How many ounces is a gulp? 3 ounces? Maybe that's a sip. Maybe we're going to call this sip. So this method increases our variable. This method decreases our variable. Maybe let's read the variable. Public void. Now, over here is where we're ultimately going to be calling these methods. But what I want to do is I want to say, okay, let's return the number of ounces left in the coffee cup. What would you call this? If you just want to see how many ounces are left, let's check ounces remaining. So I'm gonna look. Essentially, this is looking in the coffee cup to see how much is remaining. Now, what we're doing here is we're gonna make this variable. We're gonna make this variable accessible to the form, right? But we're gonna do it in a controlled manner. So with data hiding, the instance fields are marked as private, which makes them secure. Only with controlled access through the methods can a piece of data be revealed. Okay? And here, what this method is going to do is it's going to return our current ounces of coffee. So this is an int. So our return data type is going to be an int. And I'm going to return current ounces of coffee. Now, what am I talking about? The controlled access. Well, I could say something like, you know, if the user has permission, return the number of ounces. Otherwise, don't give them access. Okay, so there can be all sorts of if statements and for loops and all sorts of things to determine whether we want to actually expose this data. Okay, so data hiding is this concept that our instance fields, that our variables are private, and only through controlled access of our methods, and there's some other things besides methods, can you access the data. Now, I'm not really implementing any of these scenarios where they can't access it. I'm just kind of giving them direct access. Okay, so let's actually see a little bit what this looks like. And by the way, this is not exactly a standard class, and I'll talk about maybe a more standardized class. But let's go over here. Let's click a button, and oh gosh, let's at least give it a button. All right, sell the coffee cup, and button sell coffee. Okay, so we've now created this class called coffee cup. Remember, classes are blueprints of objects. All that means is when you use the class, you create an object. And that's done simply by saying coffee cup. My coffee is new coffee cup. So let's talk about these different pieces right here. So this line right here, line 45, creates an object. The data type is coffee cup. Just like your int is a data type and your string, you know, we're creating a data type here. So our data type is our coffee cup. So when you say, you know, what is this right here? When I just highlighted, that's our data type. My coffee is the identifier. Equals new coffee cup. Okay. New is the keyword that creates an instance of an object. So anytime you see the keyword new, that's like saying we're going to use this coffee cup class and create an instance of it. By the way, at the end here, we got these parentheses and semicolon. Anytime you see parentheses, you should think that's a method. Coffee cup. So let me just break that. Let me break that off. Equals is the assignment operator. New is the keyword that creates an instance of a class, which is an object. Coffee cup. Remember, coffee cup is a method. This is a method call. We're actually calling a method here called coffee cup. Now, this method is given a special name. This method is called the constructor. you know, the constructor in construction, if you're out there building a home, the constructor is the one that actively, you know, reads from a blueprint and builds a kitchen, right, off of the blueprint, right? The same thing here. This constructor reads from the class, okay, and can build your coffee cup in a certain way. Okay, now this coffee cup, we're not building it any certain way. What I mean by that is maybe with this constructor, every new coffee cup I want to fill up with 8 ounces by default, right? Right now, my coffee has no ounces. Let me show you this. I have a label here. That label is called label 1. Let's give this a LBL ounces. So all I've done here is I've set my coffee. Now to access my coffee dot check ounces remaining. That's the method that we wrote. Let's put that in a label. Label. Remember, this check ounces remaining returns that int of the number of ounces, but label. Did I just label that? Label ounces dot text equals I'm going to do another example after this. I think this method returns an int. The way that you call this method is by saying identifier dot name of the method. The name of the method, check ounces remaining. Now, this constructor that we called is called the default constructor. Sets all your instance fields to default values. Like 0 for ints, 0.0 for doubles, decimals, and floats, false for Boolean, null for strings. So this default constructor gave all of our instance fields default values. So when I print out the number of ounces of coffee, because we never modified, we never put data into it, it should just print out 0. Okay. See, ounces of coffee is 0. I created an object and I reported its number of ounces, which is 0, because that's the default because of the default constructor. Yeah, what I mean by an instance of a class. Check this out. So my coffee is one instance. Coffee cup, because this is reusable, I could do your coffee equals another instance of the coffee cup class. So my coffee is one instance, your coffee would be another instance. So they're separate coffee cups. Does that help, Dylan? That's an instance. It's like a single representation of a thing. And that's 5 minutes later, yeah. Yeah, and I'm going to get into Evan, you're correct. Those are called properties. Like forecolor is a property, and that's a property that modifies the instance field. We'll get into that. We'll get into how properties play a role. But you are correct there. Okay, so you can have multiple coffee cups. Okay, so let's do this. Because I'm printing out my coffee check ounces remaining. So I'm going to do my coffee dot fill cup with 8 ounces. So what did that ultimately do? Fill cup with 8 ounces came into here and it modified an instance field. It modified an instance field. These are up here are called instance fields for my cup. It didn't modify Dylan's cup with 8 ounces, right? It modified my cup with 8 ounces. So it filled my cup with 8 ounces because I said my coffee fill with 8 ounces. And if I say my coffee dot sip, it's going to take away 3 ounces. My coffee dot sip is going to take away 3 ounces. So it filled with 8, took away 6. This should print out 2. There's 2 ounces of coffee. It's so important to understand that all these methods are doing, most of the time, these methods are just working with the data. But they're working with the data in a controlled way. When you're creating a class, you get to determine how the data gets modified. In this case, I modified the data by 8, I modified the data by 3, and I gave access to the data through this method. So the instance fields are modified or accessed with our methods. Modified or accessed with our methods. All right, so now if I come back over here, I could say your coffee fill with 8 ounces, your coffee sip, ounces of my coffee, and I'll say plus equals ounces of my coffee versus ounces of your coffee. And all I got to do is change my coffee.check ounces to your, wait a tick, what do I call that? Your coffee dot check ounces remaining. So I sipped twice off of mine and once off of yours. So I've got 2 ounces left on mine and I've got 5 ounces left on yours. And that's full of typos and everything else. Let me put in a new line here. So what have we done? We created a class that allowed us to have this thing. This thing is a coffee cup. The thing has data and it has methods. The data is private. The data is typically called instance fields. Instance fields are private so that we can hide the data. We hide the data for security purposes, and then we make the data accessible through methods, right? Accessible meaning you can read the data through methods or you can modify the data through methods. All right, I'm going to do another example after we take a short break. We've been going for 50 minutes. So I'm going to give you guys a little breather and I'm going to do another break, another example, okay? Let's break. Pausing. Okay, back from a short break. Let's do demo number 2 and I'm going to talk less and code more. Someone pick a thing. Give me a thing to create. Can we do one with the text box? Sure. A wiffle ball bat. All right. We're going to ask the user for a brand of wiffle ball bat. Let's create a class. Add a new class. The convention for classes are capital, starting with capital, camel, a Pascal casing, but most of the time your classes are singular. So we'll just call this bat.cs because I'm just thinking, well, we could have wiffle ball bats and we could have baseball bats, wooden and plastic, right? So just what the heck, we'll say bat. Not to be confused with the animal. Typically, let's keep our classes public. What instance fields should we have? What data about a wiffle ball bat or a bat do we want to work with? We already said brand, right? What access modifier are our instance fields? Private string brand. Private string, we'll call it bat brand, bat weight. Now bat weight's going to be more like probably a double. We said, yeah, we'll just do brand and weight. So we got bat brand and bat weight. Keep in mind these instance fields modified and accessed with public methods. We're going to set the bat brand with a public method. We're going to input. We're going to have one input parameter. We'll just call brand. So from the form, we can pass in a string. And ultimately, always keep in mind what's changing. What's changing is on the left of the equals. So what are we changing? We're changing bat brand. What is bat brand? That's our instance field. We're setting bat brand equal to the value that's passed into the method. So we're modifying our instance field with the string that's being passed into the method. By the way, these methods that modify our instance fields are called mutators. Mutators are methods that modify instance fields. Public void set bat weight. Double weight. Bat weight equals weight. the instance field is being modified to be assigned the value that's passed into the method. Now let's read. So if you think these mutators, this is kind of like a write operation. We're writing to the instance fields. We're writing data into the instance fields. So if mutators modify data, reading accesses them. So you'll notice these mutators, they have a void return data type. They just modify data. That's what this did. But these methods are going to return data. So public, if we're going to return the brand, we're going to return a string to the form. The form's going to call and get the data from the instance field. We're going to call this get bat brand. And this is going to return the instance field. The instance field is called bat brand. This one is get bat weight. So these are what I would call boilerplate accessors and mutators. Accessors are here. They're accessing the data. Mutators are modifying the data. These are methods that access and modify instance fields. These instance fields are private for data hiding, and we control access and modification in these methods. So we could say something like in here, when you're going to set the bat weight, if weight is greater than like an 11, there's a cork in the bat, and do not allow it. So maybe you would say weight is something like equal to a -1. Bat weight equals an invalid value, -1, because we're controlling access to the bat weight. We're saying, hey, if this weight that they're passing in is too much, don't allow it. Otherwise, set the bat weight. This is an example of controlling access controlling modification of the data. Right? Oh, the bat's too heavy. Invalid. Otherwise, accept it. So 2 instance fields. Each instance field has a mutator. Each instance field has an accessor. Here's our button create click. Keep in mind, let's walk through this. This creates an instance of the bat class called wiffle ball bat. The bat constructor sets all default values for the instance fields to 0 for ints, 0.0 for doubles, false for booleans, null for strings, etc. So this wiffle ball bat by default has a weight of 0.0, and it has a brand of null. Okay, by default, when you use this constructor that's empty, this is a method call to what's called the default constructor. That's actually what this is called, the default constructor. So now let's say string brand equals text brand dot text. Wiffle ball bat dot set brand, set that brand, passing it the brand. Double weight equals double dot parse text weight dot text. So we create a local variable called weight. Wiffle ball bat dot set weight. Now this is how we inserted the data. That's how we modified the data. Now to access it, again, you use the identifier dot method name. The identifier is wiffle ball bat dot get bat brand. This is a method. There's bat brand and weight. Keep in mind weight returns an int. What's a brand of wiffle ball bat? What's that yellow one that's like pretty much the Rawlings? I don't know. One second. Someone look it up. Someone look it up for me. Wiffle ball bat brands. I don't even know. I'm not finding it easily, so I'm just going to say generic. And the weight is 4 pounds. So now we're using methods to insert data and to read data. So I tried to lessen the code. Let me go back here. If I say generic brand and I said you can't have a bat that's too heavy, notice it set the weight to -1. Okay, now that's what we told it to do. That should indicate a problem, right? And we could handle that in our code somewhere. Point being is it didn't allow 15 as our weight of a generic wiffle ball bat. Okay, so that shows off the benefit of data hiding. We hide our data behind methods. And in these methods, we can control the access to the data that we allow to be set, you know. See, so someone, you know, who's coding salaries for a company for employees, if you have an employee class and the employee has a salary instance field, you know, you don't let, if there's a salary cap, a high salary, you don't allow salaries that are too high to be set through the code. You know, you can control access to your data through these methods, right? Otherwise, you could put anything into bat weight. Or you could put anything into employee salary. All right, even more condensed. I'm going to do a demo 3. Trying to condense this down so it becomes, I'm just going to do a button and a label. You might be able to tell on demo 3, I'm working with hockey players. Right click, add new class. Public class hockey player. Private string player name. Instance field. Mutator. Changes the instance field, right? Public void set player name. String name. Player name equals name. You set the instance field equal to the parameter. Public string get player name. Returns the instance field. Okay, instance field, mutator modifies it, accessor returns it. Let's go here, create hockey player. Don't call it button 1.click. The class is called hockey player. So let's create a hockey player. Hockey player. Give me a popular blues hockey player. My blues fans out there. Tarasenko. When I create a hockey player using this default constructor, their name is set to null. So let's say Tarasenko dot set player name. Put data into the object like this. Since getPlayerName returns a string, if I go back here, this returns a string, so I can put it directly into a text property. We got a string on the left, we got a string on the right. You click the button, it's going to put his name into the label. All right. getting into a little bit of a routine on how to work with instance fields, how instance fields work closely with mutators and accessors. These are just methods that modify the data and that access the data. Okay, now this is a hockey player with the default constructor. Keep in mind, the constructor is the method call, right? You're calling a method here called hockey player, but wait a minute, I don't have a method over here called hockey player. This is a method called hockey player, and it actually does exist. This is what the default constructor looks like. This is what the default constructor looks like. You don't have to code this, right? This method right here, you can see it's already called. One reference. See right there? It even knows where it's being called. This constructor is being called one time already, but you get this for free. Default constructor is free. It costs you nothing. You don't have to code it. Most of the time. Okay? If you had like a player number, it would set player number equal to 0. Check this out. I'm going to put a breakpoint in right here and start debugging. Okay, it's about to execute line 23. Watch where my code goes. It goes into the constructor call. Now I coded it, so you're seeing this. So it's setting that particular player's name to null and number to 0. Now I call set player name. Where's it going? It's going into that method that I coded, set player name. Name is passed in Vladimir Tarasenko. Player name, which is null, is being assigned the value of Vladimir Tarasenko. So line 24 executes, and ultimately what does that do? That sets an instance field for that object. That object is called Tarasenko. Then I set the text property equal to Tarasenko.getPlayerName. Notice it goes into getPlayerName and returns Vladimir Tarasenko. Let me stop that. I keep going into this constructor talk. I'm going to show you how constructors can be used like mutators. Check this out. I'm going to repeat myself on that. Constructors can be used like mutators. In other words, to set default values when constructing an object. A constructor is a method. A constructor is a method that has the same name as the class. I'm repeating myself here. Constructor is just a method with the same name as the class. It has no return type, not even null. Public access modifier. Okay, so this is a method, has the same name of the class, no return modifier, it's public. What's it called when we have two methods with the same name but a different parameter list? Here I've got two methods with the same name but a different parameter list. Josh is correct, overloading. We have overloaded constructors. Two methods with the same name and a different parameter list. Notice this constructor takes a name. And what did I say? I said constructors can be used like mutators. It can set default values when constructing an object. So I'm going to set our instance field, player name instance field equal to the name. Doesn't that look a whole lot like a mutator? Let's go down to our mutator. Doesn't that look just about the same? Put that down in your notes. Write that one, underline that one. Constructors can be used like mutators. Now check this out. By the way, Tarasenko, okay, I'm just going to rename him. This is the object identifier. Ooh, get out of my face. Can't hardly see. If I click rename. Come on. Oh, there we go. It's going to rename him to player 1. I don't want people to get confused that the identifier has anything to do with this is the object identifier. It has nothing to do with the value of the person's name. Right? So this is the object identifier, has nothing to do with the value Vladimir Tarasenko. Check this out. Hockey player, player 2 equals new hockey player. Now when I type this, see this. Oop, method overloads. Get out of my face. New hockey player. You see these arrows? It's really messing with me. There it is. I've got one default constructor that takes no arguments. What's that one called? The what constructor? That takes no values? We got one person. Hey, cool. The default constructor. But this constructor is overloaded. This one can take a player name. Notice. I'm trying to get the IntelliSense. If I put quotes in here, notice there is one that takes a name. Hockey player, we said Bennington. What's his first name? I'm going to call him Troy. I don't know who Bennington is. Jordan. That's a goalie, right? Look at me up on my Blues players. Not really. Notice how I'm giving him a name now through the constructor. The constructor just like set player name. And you might say, well, we got two ways of doing the same thing, and you're kind of right. One, using a constructor, use constructors to set values when the object is created. You can use the methods then any other time. So it offers a little flexibility is what it boils down to. You could set the name a couple of different ways. So if I were to say label results.text plus equals player 2 dot get player name, now these are going to run them together. Player 1 and player 2 names are going to run together. Vladimir Tarasenko, Jordan Bennington. But it teaches how a constructor can be used. Let's set player number. Wait a minute. Let's make another constructor that takes a name and a number. player name instance field equals the name parameter. Let's just call this number down here. Player number equals number. Back in our code, now we can call a constructor hockey player player 3 how do you spell Gretzky? No E. Got it. And what was Wayne Gretzky's number? Let's say he was number 99 or number 1. I thought, yeah, that's right. I had to guess. I knew it was one or the other. So this hockey player is Wayne Gretzky. He's got a number. Player 3 dot get player name. Uh-oh, I don't have a get player number. Set player name, get player name. Public int get player number. Return player number. Again, this is going to be ugly because it runs it all together, but we're using a constructor to set instance fields, much like we can use mutators. This is a mutator to set the name. This is a constructor to set the name. This is a constructor to set the name and the number. These are accessors to get the player names and numbers. Wayne Gretzky 99. So how we, on these mutators, we might have, okay, on a full-size class, you might have 20 fields. Okay, each field has a mutator, each field has an accessor, and then you can have constructors that can set any combination of the field values, right? You could have constructors that set none of them. You could have constructors that set one piece of data, 2 pieces of data, 10 pieces of data. Most of the time, mutators just work with a single piece of modifying a single piece of data, set player name. We also need a set player number. Public void set player number int num. Player number equals num. Now, a convention that I have not done yet, it is convention to have your instance fields start with an underscore. So if you see underscore player name, that is a convention that we will follow. Your instance fields start with an underscore. Okay, and let me rename this to underscore player number. So anytime you see the underscore, you know that you're talking about an instance field that belongs to a class. These are mutators. These are accessors. These classes that we create are considered business classes. They exist in an architecture in this, what they call the middle layer. The presentation layer is what the user sees. The middle layer are your C# classes like hockey player and like bat. Okay, and then the database layer is where you store the data. So a lot of times what you do is you pull data out of the database, you work with it in your classes, and then you present it on the form. Okay? Or alternatively, you can pull data from a class, pull it from the database, store it in the class, and present it on a web page. Okay? And so in your third semester, that's what you do. In your third semester, your middle layer is going to be very similar. Your database layer is, we're going to learn some database here in this semester. Okay, but your presentation layer, instead of presenting the data on a form, like we're doing here, you present the data on a website. Okay, and so that's what third semester is really all about. You take this middle layer that we're learning about here, that is, used to work with code out of the database, presented on a website instead of a form. Okay, so typically your classes are singular. You'll notice, all of my classes were hockey players singular, not hockey players. Okay, bat singular because it represents a single thing. Coffee cup singular. Right, back in this demo, I'm creating all these hockey players, right? Could I have an array of hockey players? Of course. Hockey player array called the Detroit, can't even remember Detroit's team name. Red Wings. Have an array of hockey players with 20 hockey players or 30 hockey players. Red Wings, their first player, is this is a new hockey player. So here you instantiate the array. Here you instantiate the first hockey player in the array. So you create an instance of hockey players, and then this creates an individual hockey player. Let me show you a loop for Red Wings dot length. Red Wings sub-0 is a new hockey player. So this is going to instantiate all 30 hockey players to have default values of nothing and null and empty and 0 and 0.0 and false, because all 30 hockey players are using this default constructor. And then you would say Red Wings sub-0 dot set player name some guy. Red Wings sub-0 dot set player number to 30. So remember, we can use constructors to set data, or we can use mutators to set the data. And you get the idea. Red Wings sub-1 dot set player name other guy Okay, so we can have arrays, since these are our data types, right? Just like an array of ints, we can have an array of hockey players. And of course, we could interact with the form a little bit more, asking the user to input the player names and to input the player numbers. So any noun can be a class, and so in the book they use this example of the product class. And let me condense this down. So we've got a hockey player. Hockey player has an instance fields. What you find out is that all these different things, like a constructor, what does a constructor do? It works with the instance fields. What do these mutators do? They work with the instance fields. What do the accessors do? They work with the instance fields. Well, I'm going to show you another thing that can be used to work with instance fields. So those are constructors. These are mutators. These are accessors. There's another thing. These methods are kind of the old school. Mutators and accessors are the old school way of working with instance fields. Okay, C# introduced something new. The newer technique in C# is a property. Okay, a property. Now, exactly what a property is, you've been working with properties. The text property of a label. Okay, the text property of a text box. The visible property of a text box. The button, the name of a button, the name of a label. Those are your properties. Okay, and C# works with properties. Let me show you a property. They start with the public access modifier. The return data type is string, so very much like your accessor, name. So this is our property. This is called a property. Properties can have two blocks of code in them. A get block and a set block, just like your accessors and mutators. So we say get return underscore player name and a set. So the get block is just like your accessor, returns the player name, right? Didn't we do that right here? Returns the player name. So this is a property that does the same thing as an accessor. And what do you think the set does? It sets the player name equal to, there's a keyword value. Value is a keyword that means that when you set the name property, whatever is passed into is the value. So string is the return data type of player name, and what's going to be coming in is this value. So this is called a property. A property does the same thing as an accessor and a mutator. Okay, if you put both of these blocks in here, this is kind of like a shorthand for doing two of these methods, for the set and the get. And I just did that on name. So let me show you how to use this one. Right, so now we've got Red Wings sub 2. Now we can use the property. Now that we've created the name property, and the Red Wings are progressive. So we got some, the first woman. So we got some gal that's now playing for the Red Wings. Red Wings, and we can set her name with the property. So what does that property do? Well, that property modifies the instance field. What does the mutator do? It modifies the instance field. What does the accessor do? It accesses the instance field. What does the constructor do? It modifies the instance field. So this is like the everything at once. I mean, again, what have we all learned? Everything works with instance fields, constructors, mutators, accessors, properties. All of these things exist to work with instance fields. Ultimately, they do this to implement data hiding. which is an object-oriented feature that basically says you can only modify and access your data through controlled mechanisms like properties, mutators, and constructors. Everything's about the instance fields. Exactly. If you look at the code that's generated for like a button, if you actually go into here, go into the form designer and expand this out, if I say button, these are properties of the button. The location property, name property. Let me see where I actually instantiate the button. Here we're creating a button object. Here. Let's see, somewhere in there's new button. Somewhere in here there's going to be new. Oh, there it is. Button create. Button create is a new button. We create an instance of the button. We set the location property, the name property. So there's a lot of code that's going on behind the scenes. Now, a lot of people who've studied, like, for example, Java, Java does not have properties. So this is a unique feature. If you've studied Java in the past, and there might be one person or two people that have studied Java, you probably got real familiar with these accessors and mutators. Okay, these are boilerplate stuff in Java, but not with these properties. And so, again, properties, like they're talking properties here. That's what those are. Properties are ways to work with instance fields. They're ways to read instance field values, and they're ways to write instance field values. Now, I summarized and said that everything can either be data or a method. And that's true, but they can be broken down into further things. Okay, generically what I said was true, but there's definitely more things that a class can have. We've talked about class properties. We've talked about class methods. Well, a property really represents a piece of data, right? A method is a behavior. A constructor is a method, so on and so forth. An event, all these things, a field, right? That's your instance field, right? A variable that's declared at the class level. So all these terms we more or less covered, or will cover as we go on. I mean, some of these things we cover at later times. Like an indexer. Some hockey players, we could say hockey player Sub-Zero, Red Wings Sub-Zero, but instead of using a number to index our Red Wings, maybe we could use something else, like their, because arrays are always, indexers are ways to have collections of things, but instead of them just being a zero-based 1, 2, 3, 4, 5, you could say hockey player sub player name or something along those lines. That's what an indexer is. We talked about data hiding a lot. To say that encapsulation, I always think when I think of encapsulation, I think of time capsules, because a time capsule is essentially encapsulating a moment in time, and so a class is encapsulating all of the data and all of the behaviors for an object, and so you're encompassing everything into one unit. That's encapsulation. Encapsulation is a fundamental concept of object-oriented programming, It lets you control the data and operations within a class that are exposed to other classes. So you're encapsulating the data, your fields, and the operations, your methods, that are exposed to other classes. In other words, what data is exposed and what data is not exposed, what methods are exposed and what methods are not exposed. Generically, none of your data is exposed, and most of the methods are exposed. All right, an object is an instance of a class, and so I could have 100 coffee cups, and they could all have different ounces, right? Each instance field could have a different value because they're all their own unique things. Okay, again, these are your instance fields. This is your constructor. This is your constructor. Something that you might see, a point of confusion for a lot of developers, is what the keyword this means. You might see the keyword this in the textbook. We always put underscore player name as our convention because that allows us to use player name as our parameter. So still underscore player name is your instance field, player name is your parameter. If your instance field is named the same thing, okay, if this happens, you can even say this is like, you don't want to do this. Okay, the way this recommended, this isn't bad practice because they both are the player name. It's not a bad practice to name them the same thing, but if you name them the same thing, be it your instance field named the same thing as your parameter, you put the keyword this dot, and this dot makes it clear that you're referencing the player name field and setting it equal to the player name parameter. If you don't put this dot, it actually does it backwards. It sets the parameter equal to the field, which is a mistake. That's a coding mistake. So if you name them the same thing, which is not a bad idea, you do want to use the keyword this, which this implies the instance field player name. So this refers to the object instance field, not the parameter that's passed in. So that's what the keyword this is. Yeah, the keyword this confuses programmers all the time. They're like, what does this actually mean? There's a lot of internet jokes about that. I still don't get what this is. So that's your property. We talked about properties. That's just a method that accesses some data and returns a string. So that's kind of like an acceptor, accessor. Yeah. All right. By having a product class, you can instantiate multiple products. We showed you how to add a class. Show you how to create instance fields. Again, our convention that we're going to use in this class is for your fields to be underscore notation. Okay. That's an hour and 45 minutes of lecture. I'm going to stop it off here. Okay. All new stuff. All new stuff. Lots to learn, lots to study.